Hello, this is Magnus and welcome back to another video. Today we will be going over question 9 from the vector resolution sheet from Physics 12 that we were given a week or two ago. Today we went over two methods, just going to go over them briefly. We do know the component vector method, so actually wait, let me draw this a little differently. So for any vector, we can always find a y and an x that will give of the y and x component of this vector or resultant. So this would be resultant in the y, this will be resultant in the x. This makes a right angled triangle. So to do this, whatever angle you're basing it off, there should be an angle in the triangle, and you can use trigonometry to find your y component of your resultant and the x component of your resultant. And this method is basing solely on the triangle itself, nothing else. Now, the second method is you always base your vector off from 0 degrees. So if we just draw a crosshair, this is north, south, east, and west. So east, as you should know, is 0 degrees. North is 90 degrees. West is 180 degrees. And south is 270 degrees. And as this approaches your 0, this could be 360, right? So if we have any vector, let's just say we have a vector in this quadrant. We have an x component and a y component. Now you could use this angle of reference and do trigonometry inside the triangle, like over here, or you take whatever angle, that was weird, take whatever angle it is relative to the 0 degrees, then you just pump that. So this one would look to be around 180 plus 50 degrees. So this would be around 230 degrees. A little at symbol. Now you could use just the internal angle to find your x and y component, but if you want to keep things constant, you can just always do everything from 0 degrees. It'll give you the same answer regardless. Okay, so let's go over this problem. Here we go. I'm still trying to get used to this. I'm sorry in advance. Voice sounds so weird recorded. Okay, question 9. For the following path, 50 meters north, 47 degrees west, 22 meters west, 43 degrees north, 30 meters east 60 degrees, east 60 degrees south, 30 meters east, and 44 meters north 75 degrees east. Find A, the total distance traveled, B, the displacement, C, the direction back to the start. So the first thing let's do is to draw our vector diagram. So this is going to be our start point. Okay, so we are going to go 50 meters north, 47 degrees west. So it'll be just slightly more than a 45 degree angle. That's actually a little large. We'll make this a little smaller. This is 50 meters. And we know that this angle right here, oh my, I'm so sorry, 50 meters, but the angle here is 47 degrees. Okay, 22 meters west, 43 degrees north. So if we just take this into perspective, we're going from the west and we're going 43 degrees up. But we know that the rest of the angle, actually this is actually drawn not to scale, sorry. So we're going to have a line, 22 meters. We know that this angle here is 43 degrees. But we know 90 minus 43 is 47. So technically these two vectors are actually along a straight line. Although later we will calculate them separately just because they're listed as separate vectors. Okay, next, 30 meters east, 60 south. So this is east and we want to round 60 meters south. Sorry, I mean 30 meters, sorry. 60 degrees towards south. So, we know that the angle from here is 60. I'm just going to put it here so it's a little easier to see because 90 minus 60 is 30. That's 30 degrees. This is, almost did it again. Not 60 meters, 30 meters. Okay, next is 30 meters east. So we're going to head straight east. I'll get rid of this 47. See if I can write this, if the program will let me write it smaller. There we go. I want to go 30 meters east. I'll just put 30 meters. And then go 44 meters north, 75 degrees east. So north, 75 degrees east. So it's going to be a slight incline. This is 44 meters. And we know that 90, we know this is 75, which means this has to be 15 degrees. Okay, so we have 5 separate vectors. Unlike the last video, we only had 3, so we are going to have to do some more calculations. But let's do A first. The total distance traveled, distance is a scalar quantity, so we can just add the magnitude of all of these vectors. They're all in meters, so, and that is distance. So we have our 50 meters plus 22 meters plus 30 meters plus 30 meters plus 44 meters. And this will give us the distance traveled, which is 176 meters. Okay, now for B. We want the displacement. So the displacement is going to be whatever the net movement is after all this distance traveled from our original point to our end point. So the resultant is going to be equal to this dotted line. Hopefully that's clear. Okay, so let's figure that out. So I'm going to make this a little bigger than last time because last time it was kind of shoved in the corner. So I'm going to use the component vector method. So I'm going to create a table. It's going to be my vector. This is going to be my y, and this is going to be my x. So okay. So for reference, I'm using the method where I start at 0 degrees. So like this is east. You know this is 0 degrees. So when you do it from 0 degrees, you take whatever the magnitude of, when you start at 0 degrees, to get your y component, you do the magnitude sine your angle relative to 0. And to find your x, you do the magnitude cos whatever your angle is relative to 0 degrees. So I'm not necessarily going to write it, I'm just going to write down what it is. So like our first vector is 50 meters, 50 meters, and we know it is 47 degrees north, 47 degrees west. So east to north is 90. 90 plus 47 is 137 degrees. So to find our y component, we will do 50 meters times the sine of 137 degrees. To find the x, we will do 50 meters times the cosine of 137 degrees. Okay, so y, this will give us approximately 34 meters. And this will give us negative 36.6 meters. I'm just going to keep a few significant digits just so it's slightly more accurate. Okay, next vector. It is our 22 meters. West, 43 degrees north. West is 180 degrees from east. 180 minus 43 is 137. Again, proving that these vectors, these two first vectors, are in a straight line. So 22 meters, sine 137 degrees, and 22 meters cosine of 137 degrees. Okay, so the y evaluates to be pretty much exactly 15 meters, and the x is like negative 16 meters. Okay, our third vector is 30 meters. East is 60 degrees south. So we're going to take, because it's below 0, we have to start from 360 and take away. So 360 minus 60 degrees is 300 degrees. So 30 meters times the sine of 300 degrees. And to find our x, we do 30 meters times the cosine of 300 degrees. Our y evaluates to be negative 26 meters. Our x evaluates to be 15 meters. Okay, oh, that was bad. No, there we go. Still trying to get used to this. No! There we go, yeah. Again, I'm not used to doing videos or such, but hopefully this clears confusions with our classwork. So, our next vector is 30 meters east, but we know east is 0 degrees. Sorry, I accidentally drew theta there. 0, that's a bad 0, but anyway. So 30 meters sine 0 degrees. And to find our x, 30 meters cos 0 degrees. Our y is going to evaluate to 0 because the sine of 0 is 0. And this is going to evaluate to 30 meters because cos of 0 is 1. Okay. So that is our fourth vector done. We have one more to go. I'm going to bring this down a little more. So after this, we're going to take our net x and y. So our next vector, or our last vector, is 44 meters north, 75 degrees east. So we know that is turning at 90 and it's going 75 degrees towards 0. So 90 minus 75 is 15 degrees. So that's where you're going to use relative to 0. Okay, so we have 44 meters at sine of 15 degrees. I'm going to have 44 meters times the cosine of 15 degrees. The y is going to evaluate to approximately 11.4 meters. And the x is going to evaluate approximately to 42.5 meters. So now we're going to take our net. Okay, so F net, or F net and the y. Oh no, that wouldn't really be accurate because it's not force. How would I draw that? I'll use resultant in the y. No. Question specifies displacement. So displacement in the y is equal to 34 plus 15 minus 26 plus 11.4. So that will equal approximately 34.4 meters. Now for x, this is minus 36.6 minus 16 plus 15 plus 30 plus 42.5, and this will equal approximately 34.5 meters. No, what am I doing? It's not at all what it is. Sorry, video difficulties. I apologize in advance. I did the question, and then I rounded slightly different for this video, just so it was a little simpler. So answer might be slightly different. Yeah, so it's going to be, sorry, again, in advance, 34.9 meters, and that is our displacement in the x. So we know these are very close. Like, this is almost like isosceles right angle triangle, but not quite. So this is our displacement in the y and displacement in the x, and if we go back up to the problem, we know it's going to be a triangle going this way and up. But we want to find the resultant. So I'll probably put B because we're doing B here. So this is going to be our triangle. Okay, so our net y is 34.4 meters. Our net x was 34.9 meters. We can use Pythagorean theorem to find our displacement at an angle theta, which we haven't found yet. So displacement squared is equal to our, how do I undo? There we go. Okay. Displacement squared will equal our displacement in the y squared plus the displacement in the x squared. Displacement will equal the square root of 34.4 meters squared plus 34.9 meters squared. So I'm at a slight angle here. Try to straighten this out. Is equal to the square root of 34.4 squared. This is, wow, why isn't this? Here we go. 1,183.36 plus 34.9 squared, which is almost the same number, 1,218.01. Again, I apologize, this is at a weird angle. Displacement is equal to the square root, this number, plus 1,183.36. Displacement is equal to the square root of 2,401.37 meters squared. Oh, I'm sorry. I just noticed I forgot to put meters squared up here. I know a lot of people in our class don't use units, but I always do. So for those that do use units, I apologize. I would usually always do that. And the square root of this is pretty much 40, it's literally on the dot, 49 meters. This displacement is 49 meters. But this question asks for the direction to head back to the start. But take into account that whether this question asks you to find the angle back or not, it wouldn't matter, because vectors always have to have direction. So this is where we're going to find our angle. I'm going to use the same reference triangle, but I'm going to get rid of theta here. And that was bad. I only want to get rid of... No, stop. Okay, forget about that little line. I'm going to put theta up here because we want the direction back to the start. So to do this, we're going to label from this angle theta, this is opposite, this is hypotenuse, obviously, this is adjacent. So we're going to use our tan ratio. Tan theta equals opposite over adjacent. Theta equals the arctangent of opposite over adjacent. Theta is equal to the arctangent of opposite, which in this case is 34.9 meters over 34.4 meters. Whoa. Theta is equal to the arctangent of 34.9 divided by 34.4. This gives us the tan of 1.0145348. You can write as many decimal places as you want. That's just what's on my calculator. My calculator usually goes to 10 numbers on the screen at once. Theta is going to equal to 10 to the negative 1 of answer. And this is equal to 45.4 degrees. Usually angles is to the nearest degree, so I'm just going to write this as 45 degrees. So we have found all parts of this question. We found the total distance traveled, which is 176 meters. We have found the displacement by using all of this component vector method to find the x and y of every single vector and then add them up so that we have a net x and y, which then gives us a nice easy right angle triangle to deal with to find our missing side using Pythagorean theorem. And finally, to find our angle, we use our tan ratio. So that is question 9. This is probably the most difficult question on this worksheet. I know number 8 did cause some confusion, but I'm not going to do every question on this sheet because then I'll just be giving all of you the answers. And also, if you do plug this stuff into a vector calculator, whether your calculator does that or whether you look one up online, just make sure all the angles are relative to 0 degrees. So make sure you punch that in correctly. That will give you the answer, because I know the answer is on the back of this sheet. Most of them are false. Well, anyway, I hope you enjoyed the video, and I hope you understand how to deal with multiple vectors. These questions will pretty much always be the same. They'll give you a ton of vectors. You'll get the xy components for all of them, make your right angle triangle, you find your missing side, and then you use tan ratio. That's the way it works. Hopefully you now understand how to do this better, and you are ready to go out and do the rest of the questions on the sheet. Anyway, hope you enjoyed, and I'll come back in another video, hopefully soon.